All right, hello. I'm going to answer this question about given triangle ABC with angle A's measure equal to 31 degrees, angle C's measure equal to 52 degrees, and side length B equal to 47. Find the length of side A. So first things first, you need to draw a diagram, figure out where everything is. We already have here, I've drawn triangle ABC, and capital letters are usually used to be the vertices of the triangle. And when you're doing these problems, the side across from the angle is often labeled with a lowercase version of the letter for that angle. So where we have angle C, for instance, across from that would be side C, and we'd use a lowercase c. So they're across from each other. And then we can do side A is across from the uppercase A, and side B would be across from the capital B. Okay, so once we set it up like that, we know that we have angle A's measure, angle C's measure, and side length B. We don't know angle B's measure, but we can find it really easily because we have the rule that all the angles of the triangle in black. I'd put that in black. Here we go. All the angles added together should equal 180 degrees. And so we can fill in the information we know. We know that angle A's measure is 31. We know that angle C's measure is 52. So then we can solve that equation. We can subtract 31 and 52 from the 180, or from both sides, really. So we get here B plus 52 equals 149, and then we subtract 52 from both sides. And so angle B's measure is 97 degrees. And so now we have all the angle measures for this triangle, and we have one side length. Now, if you know even two angles and one side length, you're going to be using the law of sines. There's also a law of cosines, which you can use when you don't know the law of sines. But we do know the law of sines here, so what we're going to do is we're going to figure out what this law of sines is. It's a nice, easy one to remember, because the matching pieces are always put together in this rule. So we have sine of A, and then in the denominator we'd have just A, lowercase. We have the sine of the angle over the side length across from it. And then we fill in the next one. That would equal the sine of B over side length B. And then that equals the sine of C. Let's put it all in the right colors here so that we can see it. Sine of C over C. Right, and so what you look for is you look for a way to fill that all in with information that you know. We do know all the angles, so we could use any of those fractions, but the side that we know is side length B, so we definitely want to use this fraction. And then we're looking for side length A, so we definitely want to use this fraction. So we're going to set those up, and we're going to kind of ignore the C's. We're just going to throw this fraction out because we don't really need that one to solve this problem. And so then you would fill in sine angle A over A, sine angle B over B. So you would do the sine of 31 degrees over A. We don't know what A is, so we're going to solve for that, equals sine of B, so sine of 97 degrees over 47. And you can solve that. You're trying to get A by itself. You can also do this rule always the reciprocal. So you could do A over sine of 31 equals 47 over sine of 97. It's just always easier to solve for something if it's in the numerator, so maybe doing the reciprocal version would be easier. You multiply both sides by the denominator sine of 31, and when you multiply that to both sides, you should be able to get your answer. Good luck finishing it off. Have a great day. Bye.